Welcome to this explainer. Look, if you're an IT support engineer, a QA tester, or a developer working with secure APIs, you already know the pain. We've all been there. You're deep into a complex testing flow, you hit send, and boom, you get hit with that soul-crushing 401 unauthorized error. Your token expired. Now you have to stop everything you're doing, authenticate all over again, and manually manage that token. It's incredibly frustrating. It completely breaks your flow, and frankly, it wastes a ton of time. Well, today, we're going to fix that. I'm going to show you a highly pragmatic, automated way out of this trap using Postman.
We are leaving the painfully manual workflow in the dust. You know the one, getting a 401, scrambling to find your login request, meticulously copying a massive string of gibberish and pasting it into your headers. Instead, we're building a totally frictionless reality. Imagine this. You just click send. That's it. If the token is missing or stale, Postman just silently fetches a new one in the background and injects it for you. It's basically magic.
So here is our roadmap for today's explainer. 1. The manual token trap. 2. What are pre-request scripts? 3. Writing the send request script. 4. Automating the authorization header. And finally, 5. A real scenario testing 10 endpoints. All right, part 1. The manual token trap and how we finally escape that dreaded 401 loop. Let's just quickly review the tedious process that bogs down so many of us daily. Step 1, you send a post request to your login or token endpoint. Step 2, you carefully highlight and copy the access token from the JSON response, usually praying you didn't accidentally highlight the quotation marks. Step 3, you navigate all the way back to your main API call and paste it into the authorization header. And step 4, you repeat this entire dance every 15 to 60 minutes when the token inevitably dies. It gets so old, so fast. So the big question is this. What if you could extract that token automatically and literally never copy and paste it again? By tapping into Postman's built-in automation, we can completely eliminate this chore. Let's peek under the hood at the feature that actually makes this possible.
Moving to part 2, what exactly are prerequisite scripts and how does the execution hierarchy work?
Think of a pre-request script as a silent pre-flight check. It's essentially JavaScript code that runs asynchronously in the node-based Postman sandbox right before your actual HTTP request fires off. It intercepts your action before it ever leaves your machine, which gives you the perfect window to run logic, set variables, or, and this is exactly what we're going to do, make a quick side-channel API call to fetch fresh credentials.
Now, a quick heads up on a very common pitfall here. A community member tackling a Postman API challenge shared a really hard-learned lesson. They noticed their requests were still failing with stale tokens, and it turned out to be a timing issue. Postman scripts run asynchronously, meaning if you aren't careful, Postman might build the synchronous request headers before your script even finishes fetching the new token. So we absolutely have to ensure our fetch token is securely saved to the environment before the main request tries to use it.
Okay, section 3. Let's get our hands dirty writing the send request script and automating that fetch.
We're going to break the logical flow of our script down into 3 super straightforward steps. First, we'll use a built-in method called pm.sendRequest to call our auth server. Second, we parse the JSON response body to grab the token. And third, we lock that token into a dynamic environment variable. Let's look at step 1. This pm.sendRequest method is a total game changer. It acts like an intelligent side channel operation. So while your main request is just sitting here waiting to launch, this little script reaches out to your token endpoint. You configure it exactly like a normal request. Give it the URL, set it to post, pass in your credentials in the body, and it waits for the server to reply, dumping the results straight into a callback function. Once that callback function triggers, we parse the payload. The line letJSON equals res.json just transforms that raw response into a workable JavaScript object. Then comes the magic line, pm.environment.set. We pass in our variable name. Let's call it access token, and the value we just parsed. Boom! Your fresh token is now securely stored in your environment. Now, why environment variables specifically? Well, as community expert Don Vontery points out, always use environment vars. While Postman does let you use global or local variables, environment scopes are hands down the most robust for this kind of workflow. It means you can seamlessly swap between your local, staging, and production environments without rewriting a single line of your script. Plus, they persist across your session, so the token is just ready and waiting for whatever request you throw at it next. Section 4. Automating the authorization header. Let's set up the auto-inject.
Okay, so our script is doing the heavy lifting in the background, but we still need to tell our main request to actually use that fetched token. Luckily, it's incredibly simple. You just navigate to the Authorization tab of your request, select Bearer Token for the auth type, and then in the token field, you use the double curly brace syntax. Just type curly brace, access token, curly brace, curly brace. That syntax tells Postman, hey, dynamically pull whatever value is currently sitting in that environment variable.
Look at the difference this makes. You are officially trading a hard-coded, highly brittle token, one that guarantees your API calls will fail the second it expires, for a fully dynamic, automated reference. You literally never have to touch this header again. Your pre-request script acts as a bouncer, guaranteeing that @access token is always populated with fresh, valid credentials before the request even leaves your computer. Finally, Section 5. Let's look at a real scenario with 10 endpoints to see the actual IT support payoff.
Picture this. You're on the IT support desk. A critical issue comes in, and you need to rapid-fire test 10 different secure endpoints back-to-back just to isolate the bug. If you do this manually, you'll be authenticating over and over, completely losing your train of thought. Instead, you take that script we just wrote and you paste it at the folder level in Postman. Because of how Postman's execution hierarchy works, that single script now runs automatically for every single child request inside that folder. The result? 0 manual auth interruptions. You just click through all 10 tests, seamless as can be.
By eliminating that manual token grind, engineers are reporting a massive chunk of saved time. We're talking about clawing back over 20 minutes per testing session. When you aren't actively fighting your tools or hunting down expired tokens, your troubleshooting flows remain completely uninterrupted.
The numbers really speak for themselves here. That old start and stop manual workflow easily stretches a testing session out to 25 minutes of pure frustration. But with the automated pre-request script in place, your actual testing time drops to under 5 minutes. API layer testing becomes exponentially faster when you just remove the human bottleneck of copy-pasting credentials.
So, you successfully crushed the 401 loop and automated your authentication tokens. That is a massive win for your daily workflow. But it should really get you thinking about a much bigger question. What other repetitive API tasks are silently stealing your time right now? Could you automate your test data generation? Could you script your teardown processes? Start looking at your daily bottlenecks through the lens of Postman automation and take your time back. Thanks so much for joining me on this explainer, and happy building.